Hi everyone, Mr. Benjamin here, and today we'll be going through 2015 paper 2A question number 2. So let's read this question together. Metals are extracted from their oxides by reduction. So this is the reaction where you get a metal oxide and then you add a reducing agent, most of the time carbon, to form your metal plus carbon dioxide or carbon monoxide. So the table here shows the minimum temperature needed for the reduction. So you can imagine that the higher the temperature, right, the more difficult, the more energy is required for the reduction. So you've got a different type of metals here on the left, and then we've got a temperature on the right. So question A1, how does the temperature needed for reduction relate to the reactivity of the metal? So once we see the word reactivity of the metal, we know that we need to list out the reactivity series. So we're going to list them out. So please stop calling me a cute zebra. I like her calling me sexy goat. I need to circle the second C because that's carbon, the non-metal, and H, which is hydrogen. Alright, so over here, we're going to see how does the temperature needed for reduction relate to the reactivity of the metal. So in this question, the format of answering is actually very important. So we can see as temperature, oh no, let's do that way. As reactivity of metal increases, okay, so this is the format. So as something increases or something decreases, so let's see, we have calcium, which is here, very reactive, right? And then we have magnesium, also very reactive, but less reactive than calcium. But when we get less reactive, it seems that the temperature decreases. So we check, the copper seems to be the least reactive here, right? So 1, 2, 3, 4, 5. Copper's like number 5. So copper seems to be the least reactive and the temperature is the lowest. So when we see that the reactivity increases, the temperature also seems to have increases. So as the reactivity of the metal increases, temperature needed for reduction increases as well. So the more reactive the metal, the higher the temperature needed for reduction. So they want us to do iron oxide. So based on the trend that we determined on A part 1, we can see that iron is over here. Iron is over here and it's in between zinc and lead, which is this one here, zinc and lead. So therefore the temperature should be somewhere in between zinc and lead. So I think I'll give any temperature between 500 and 800. So let me do maybe 650. Okay, so the reason is since iron is more reactive than lead and less reactive than zinc, temperature would be between zinc oxide and lead oxide. Okay, so that's how you answer this question. So let's look at part B, right? Metal oxides also react with some metals, right? So we're going to look at the different metals. So we got the metals here and we got the metal oxides over here. So which one will most likely react to be the most vigorous? So most vigorous means there must be the biggest difference in reactivity. So biggest difference in reactivity. So biggest difference. So if you look at our reactivity series, let me just write it out one more time over here. Please stop calling me okay zebra. I like her calling me sexy goat. Right, so we want to look for the biggest difference. So N, right? The metal needs to be more reactive. So let's go with the most reactive metal, because you know the most reactive metal can displace a lot. So let's see magnesium, which is over here. And then the least reactive would probably be silver, right, which is over here. So that's quite a big difference. If the metal oxide is potassium, then nothing over here can displace it. So we need a very reactive metal with a very metal that's not so reactive, the metal oxide. So the biggest difference so most likely it will be magnesium as the metal, and then it will be not potassium, silver oxide as the metal oxide. So the biggest difference in reactivity for the most vigorous reaction. Alright, part C. Zinc metal reacts with steam. So we know that this is 4,4, so please stop calling me. And then 4,4, so zinc, yes, reacts with steam. So what are the names of the two products? So most of us know names are, so we know that hydrogen is supposed to be there. Okay, so this is a displacement reaction. So we have zinc, and then we have water, which is steam, and we are sort of displacing the hydrogen, so the hydrogen comes out. So what is the other product? So if you displace the hydrogen, the zinc will form zinc oxide. So the other product here would be zinc oxide. Okay, so I hope that helps you to answer 2015 paper 2A question 2. All the best. Bye.